Okay, so this is Mr. Bob, and we're going to try and explain how we can use Newton's second law and force diagrams to solve problems of how objects move and how we can predict how they'll move. So let's start with a common everyday occurrence. Let's say you have a box sitting on the ground, and you need to move that box from here all the way over here. And so, in order to do that, what are you going to do? You're going to have to push it. You're going to have to apply a force to it in this direction. Making a recording. So we can label that as an applied force, FAPP. And let's say that force that you apply is 400 newtons. Okay? Well, we know from our everyday occurrence that there's going to be some friction that opposes it. Let's say the frictional force between the box and the ground turns out to be 150 newtons. And one last thing we need to know, let's say the mass of the box is 50 kilograms. Okay, so how do we figure this out? How do we figure out what the acceleration of the box is going to be? Well, we know from Newton's second law, the acceleration of the box depends on two things. The net force divided by the mass. How do we figure out the net force? The net force is the sum of all forces, and we have to add them up in each direction. So let's first take the x direction. It's this direction. So what we're going to do is we're going to take sum of the forces, and that's just a fancy Greek symbol, it means the sum. In the x direction is 400 newtons minus 150 newtons. What do we get? That's 250 newtons to the right, and that's our net force in this case. So then we use this, and we'll plug it into the equation with acceleration. So A equals 250 newtons, and then we'll take the 50 kilograms. Let me see if I can figure out how to do colors here. There must be a way to do colors. Yeah, there we go. Awesome. So then, I want to take the 50 kilograms and I'm going to put it down here. 50 kilograms. What does that equal? 250 by 50, that's 5 meters per second. And there you have it.